Hey guys, it's Nick and it's the first tutorial in 2021. It's a Houdini tutorial. We will be checking out Vellum grains and doing magnetic sand simulations. And if you follow this tutorial, you will be able to do something like this. Alright, first of all I want to say a huge thank you to everyone who subscribed to my YouTube channel or to my Instagram and support me leaving a like or even purchasing the project files on Gumroad. For this project, the project files will also be available on Gumroad. It's only $2, so yep, if you want to support me and maybe want to save your time, like not redoing all the stuff from scratch, yep, feel free to check it out and download. So let's start. So let's open up Houdini, drop a geonode, and let's name it grain source. So here let's open it and let's drop a tube. Click the end caps, primitive type to polygon, like 48 columns. Height could be 0.2 and radius scale should be like 5. Should be pretty big disk. Now here let's drop a transform node. Let's attach tube to the transform node. Visualize transform node by clicking this right side button. And in translate, let's write down a handy expression. It's minus $y min, and what it does, it places our tube like with zero, like bottom edge is on the zero of y-axis, like this. Alright, now let's hop out of the grain source, but yeah, maintain selected this transform node, and let's find out Vellum on the top shelf. It should be where it is. Crowds, fires, Vellum. Oh, here it is. So Vellum, and let's click Vellum grains. So this will automatically create the dot network and the grain system. So let's open up grain source once again. Here you can see there's grain constraints, and basically this determines how densely you can pack your tube. Now we can experiment. You obviously want this grain size to be big enough just for now, as we will be trying different things out, but for me I was rendering it, I think it was 0.05 maybe, or even 0.03. Yeah, 0.03. Yeah, but I wanted really fine detail, so if you don't want, just stick to 0.1 or perhaps 0.07. Yeah, this should be good. And also we can open jitter scale, and not open, but yeah, checkbox the jitter scale. It will make it not that uniform, but it will increase some randomness, so this will look natural. Let's go outside on the grain source and let's visualize our dot network. So in our dot network you will see your grain source. This is basically 2 nulls after the grain constraints in the grain source geo, and this Vellum object. So also there is kind of special Vellum solver. You can check, it's not like your usual Vellum solver. But yeah, anyways, we need a ground plane. Also, we need a static solver, so our collisions with the ground plane actually work here. Let's make sure that in the merge we have static solver first, and after that the Vellum solver. So this should now just work. Yep. Alright. Cool. So now we don't need also this merge. Let's delete it and spawn pop grain. Pop grains is basically here in the Vellum solver. I see that basically there are some attribute that we can modify, especially like for the friction. But in the pop grains, you can experiment with these clumping parameters, and still there are like a lot of more parameters to tweak. So in my project, only thing that I tweaked was like the scale kinetic. I pushed it to 0.8, just so it brings kind of more friction, so the grains are not like rolling away that fast and that easy. So but you feel free to like experiment with this. Also, this tutorial is kind of like quick, and I'm not like explaining pop grains in depth. But one great thing about the Vellum grains especially is because Vellum is actually GPU accelerated, and if you don't have like crazy CPU like, I don't know, Xeon or Threadripper or something like that, it's always faster to do simulations on GPU. Especially in my case, I have the Intel i7 and RTX 2070 GPU, and it's much more easier to like calculate all these things on the GPU. Alright, now let's bring this magnetic fields and all that stuff into our scene. So it's up to you what objects to use. You can like use any like you can just download a vector, trace it or extrude in Cinema 4D, and bring your OBJ or Alembic or FBX files here, and you can use like this extruded object. You can use any letters, you can use any primitives, like any kind of stuff. For now, just for like easiness of understanding this tutorial, I will be using just primitive geo. So let's drop a geo, let's name it magnetic object. Here let's drop a tube, let's drop a poly extrude. Alright, so here in poly extrude, distance should be like something like this. We should also increase divisions, like something like this. Tube should be polygon, should have like 36 columns, a bit more rows, like 10 should be good enough. Yep. And maybe radius scale should be like, no, not 3, but 2. Alright. Now we need to drop normals. And normals are, it's an attribute attached to the vertex. But we will be like working with points in .NET, so we need these normals to be actually like point attributes, not vertex attributes. So easiest way to do that, attribute wrangle, this, and here you see we have 2 point attributes, normals and position. If anyone's know a faster way doing this, Please let me know down in the comments or shoot me a DM. I mean, there are obviously tons of ways of achieving something in Houdini, but yeah, that's how I do it. Let's drop a null, and let's call this null tube. Oh, all right. Now let's go into our auto dop network, and here after the gravity, let's add force, field force. All right. Now we need to add subgeometry, which is basically our magnetic objects and our tube. So now we need to add position, not obj position, but just position. Position, right? All right. So attach position, attach subgeo. Position should be first, and subgeo must be second. Here in a field force, you want to change the force attribute to n. This is our normals, and you will see these guides. Let's talk a bit about field force. So max distance is very crucial in this step, because if we uncheck it, these forces will go infinite, and all of our grains will be blown away. So you need to limit it, use max distance. Also, if you want to animate, actually let me show you what exactly is going on. So you see that our forces are pushing the grain away. It looks like this. If you will render it out, it will look like this. And you may want to actually animate this scale force, let's say from 0 to 1. And I was trying to find this procedural way of doing this, and maybe because Houdini is that complex that at some point you start to realize that easy solutions are wrong, but it's not that case. And here in my project I just set a keyframe, Alt plus click, and say 0, set a keyframe, set it to 10, and also keyframe it. Yep, so this is how you animate them. Be sure that if you are animating, you need to set the default aberration to set always. And also here in the position, you also can animate the position of this subgeo, and you also need to change it to set always. But you may see that let's bring it to 1 and let's see what happens. Alright, nothing actually happens. Let's bring it to 0.5. And maybe increase the field. Oh, okay, scale force is 0. So yeah, let's do 2. Alright, so this is the result if the position is 0.5 on y-axis, and if we set it to minus 0.5, so you see how it pushes this ring up. It will be kind of cool effect though, but you see it will bounce up and down, and this is basically because of this limit of the max distance. So as soon as it hits 1 here, it starts dropping again, and here it also gains its force again and goes up. and it will be like pulsing this infinitely. So this is first thing that I wanted to show you, and the second is actually stacking these field forces. So here in magnetic objects, let's just copy this. Let's name our null to box. Poly extrude, we don't need that. Box. Let's make it like 10 and 3. And also don't forget that we need these points, vertices, and after that we convert them to points. So we need a pretty dense mesh. Think something like this should work. Alright, now let's go to the dot network and let's copy our field force position and subgeo. Now let's reattach them correctly. Alright. Here in the field force, no, in the subgeo, let's just rename our tube to like box. Yep. And here, let's like visualize our box. So we see, and the position should be 0. Alright, so I think we should try 0.5, so we don't have any normals like positioning up. And yeah, let's try. So yeah, this is what I want to talk about. So you actually can stack these field forces one after each other. Like in this case, they are actually like the forces are affecting our grains simultaneously, but if you will like animate the scale force, just keyframe it, very basic animation, it will be kind of morphing or shaping our grains. So this is what actually I've done in my project, as you may saw in the beginning of this video. So yeah, one more thing you can try. Oh no, not the drag properties, but drag force. So maybe we should check these drag properties. Oh, alright, not at this time. But yeah, basically you can set the scale force to be 0.5 to maybe, yeah. If you see that your forces are like exploding and all this stuff, just use this drag node. Also, you can use negative scale force. So let's make it. Let's also rename this. This should be tube field force. This should be box field force. So if our tube field force scale force will be -3 and our box field force will be, let's say, 3, it may produce interesting results. Alright. Yeah, so something is going on. So yeah, as I said, it's a really white sheet of paper for your creativity. You can try various shapes, you can just stack them, or you can like do any of these simulations with another like field force. You can, I don't know, I think I was using 5 field forces and animating their scale force, so they are like affecting one after another. So yep, that's it here in Houdini. So you just go to your grains Vellum. This is generated node, and here you just you might want to cache it, so drop file cache. Here set it to write files, hit save to disk. After that you should click this load from disk. After that you might want to add a little bit slow motion time blend node, here evaluation mode by speed, and let's say 0.5, and after that just drop alembic output and render frame range, hit your desired frame range and save to disk. And that's all here in Houdini. So I'll open Cinema 4D and explain how you set up this with Octane render and Octane scatter. So here I imported my Alembic file, and you can see that I was like experimenting with different light setups, and let me just open this. Here we are basically dropping the Octane scatter. Let me just actually like delete, nope, not delete. So you will import your grains Vellum file, and you will need to drop the Octane scatter node. It's located here, and after that just make whatever you want to like scatter and place it here. You may want to like zoom in and check if, oh please, I mean I want just to zoom in. Alright, so maybe you would like to check if why am I seeing, oh right, if you are using the like correct size of your grains, because you need to set it up manually here. Yep, and yeah, that's it basically. Cinema 4D is obviously very limited in terms of rendering particles, but it is what it is. It's still much more convenient to assign materials, especially if those are some kind of like complex materials and you are just like experimenting, tweaking, and you don't know exactly what you want, and you are just drag and dropping different materials. But yeah, that's it, guys. So if any questions, just comment down below or shoot me a DM in Instagram. And yep, that's it. Soon there will be also a video about earning sweet money with being a 3D motion designer. Also we will talk about crypto art. I have several projects that will be rendering in like few days, so those will be a few like talky while it's rendering videos. Yeah, I hope that you will find this video helpful and will learn how to create this magnetic sand effect. That's all. Yep, thanks for watching. Bye.